Good morning. Welcome to another fun morning of Chem 1105 with your host, me, Dr. White. We're going to have a good time today. Now, a couple things. First of all, uh, let me open up Blackboard. I didn't, I should have. And let me open it up so you can see it. All right, thumbs up, people. Do you see Chem 1105 Test 1 information on your screen? Give me a thumbs up. Someone, come on. All right, thank you. All right, this came out yesterday, or late afternoon, early evening. You should have gotten a copy of this in your email also, because it was sent out to everybody. And let's go through it. All right, on Thursday, the first of, wow, it's already July. I will be giving test number one. It will be online during our Zoom meeting. Remember, this is a virtual class meeting, not an internet class. So that's time you should have booked. And what you'll do is you'll be downloading a password protected file for test one from the assignment area, which will be available sometime on Wednesday afternoon, probably. On Thursday, right after our lab, at around 10 p.m., 10 p.m., 10 a.m., I will send out an email. Uh, I will send out via email the password for the version of the test number one PDF file that you should take. There'll be two versions. I do that online always, at least for the last year and a half or more. You'll have until 11:30 that Thursday to finish test number one, upload test number one answers to the assignment area Blackboard. Now, normally when we're face to face, students get 50 minutes to do a test, and they're usually done in 40 minutes because when I write a test, I do it by my golden rule of teaching. I don't do unto my students what I didn't like done to me. And I hated tests where only one or two people could barely finish, and the rest of the class didn't have enough time. I was one of those who could finish, but still it wasn't a good feeling. I give students more than enough time, assuming you've studied and done the practice problems. Hence, assuming you've done the practice problems. All right, test number one will be covering materials in chapter one, two, and three, which I've already talked about and finished, along with appendixes A2 and A4, which I've already covered, which is in your textbook, but you don't need a textbook. Just look at the videos and the practice problems. Test one has 100 points, has 29 problems. Relax. You'll have more than enough time to finish it. And I don't always, but for this one, I put in 7 multiple choice problems. Most of them are short answer. It has 8 pages, which includes a page of those 8 with the key formulas, which is an important information file that you can see in Blackboard. There'll be a periodic table for you to download, the green one I use. If you haven't done so already, it'll be in that assignment area. I will do a review of the material on test number one this coming Thursday Zoom meeting. Students have found that my reviews help them. Plus, they're world famous, so I'll be doing it next Tuesday. And don't forget, Thursday we'll have our regular Zoom meeting for our lab. And right after the lab, you'll take test number one, which will be about 10 o'clock next Thursday, a.m. And so make sure you put that down in your calendar, or as I like to do, put a post-it on my mirror in my bathroom to remind me about important things. Uh, and the other thing I should mention, I'm making a slight change of schedule. I said yesterday, I think it was, next Tuesday, I'll go through chapter 3 problem set plus my review. I've looked at that. That's squeezing too much into lab day. On Monday, I'll go through chapter 3 problem set. On Tuesday, I'll do my review. Now, another public service announcement from Dr. White, besides you should have gotten your vaccine shots already. It will help you stay alive and healthy, which is a good thing. At least I think so, and I hope you all agree. Now, the other thing I want to talk about is after today's lab, which isn't going to be that long because we're not doing a problem set, but I'm going to have you practice a few things, then we'll do the lab. After that, I will be teaching actually, my method that eliminates test anxiety. I've been teaching it for a number of years now, and it works real well. Students who study the material know it, it's in there, but when they take a test, their brain goes, whatever. I'm a chemist, not a psychologist or psychiatrist, but this method that I've modified somebody else's method to make it even better. I do know how to solve problems. You'll find out if you stick around. Help students go from a F, D, or low C up to high B or A. You still got to study. That'll be right after lab today, but it will be cut out from the video. All right, let's get going. First of all, any questions? In that case, let me open up two things that I didn't open up. Oh, wait. You do have a lab due today, Rain, and that's the one you did on Tuesday, which Tuesday, I believe, was the density lab. That's due sometime today. I think you got until 4 or 5, or give or take an hour, to upload your answers to Blackboard. You have to use Beyond Lab Z, and that's that. Also, I just remembered I put out an email yesterday. If you have a problem with Beyond Lab Z, and I'll show you later on, you can go to their help. In the lower corner, they have a bot that you can type in what's your problem. If somebody's not there to take it right then, they get back to you within 24 hours. I've had students use that, and they've been helped quite well by Beyond Lab Z people. Well, I know some of them. If you can't get help, I'll help you get help. All right. In that case, let me open up something I didn't open up. Oh, the silence is deafening. All right. First of all, you should be seeing your periodic table that we've used in class, and this will be the one you'll download and you should use for test number 1. Now, one of the things, if this is orientated wrong and you don't have a printer, you're going to be looking at it on screen, do Control Shift, then the plus key. Again, use Control Shift plus key, and that rotates at 90 degrees. That's the first thing. All right, let's do a little practice. What I'll ask you, and then I'll tell you, how many electrons and protons does carbon have? Time's up. You should all know carbon has the chemical symbol C, and the atomic number 6 tells you how many protons and electrons carbon has. And the answer to that is 6. Oh, let's do another one. Why don't we do how many protons and electrons does neon have? And let's take a look. Neon has the chemical symbol Ne. N is nitrogen, Ne is neon, and the atomic number is 10. And therefore, neon has 10 electrons and 10 protons. All right, let's try one more. Potassium. How many electrons and protons does potassium have? And I see everybody's coming in with their answers. So let's take a look. What's the chemical symbol for potassium? K. It's right over here. It's an alkali metal. And, oh, excuse me, it has 19 electrons and 19 protons. Now, in the periodic table, you should know where the alkali metals are, where the alkaline earth metals are, where the halogens and the noble gases are. Give an example of an alkali metal, name and chemical symbol. And I'll give you another 7.6 seconds. 7.2, 7.4, 7.5. Time's up. An alkali metal, not including hydrogen, are the elements in the first column on the left of the periodic table. And in this case, you could put down Li lithium, Na sodium, K potassium. I didn't ask you to learn rubidium or cesium, but those are there too. And if you'd put that down, I wouldn't have taken all points. But I only asked you to learn lithium, sodium, and potassium. Now, give an example of an alkaline earth metal and its symbol. Time's up. Second column on the left is the alkaline earth metals. And the two I asked you to learn were Mg, magnesium, and Ca, calcium. Remember, you need calcium for strong bones. I don't know about muscles, but I know bones is important. I'm a chemist, not a physician or a dietitian or other people who study that. All right, let's do two more. Give an example of a noble gas, name and chemical symbol. All right, time's up. Noble gases are the column all the way to the right under the number 8. An example would be my favorite is argon, because I used a lot of argon gas. It's a gas at room temperature when I worked in grad school. And then Kr is krypton. And as I keep on reminding students, in our universe, krypton is not a green salad that kills Superman. It's a colorless gas at room temperature. And the last one I'd ask you to do, give an example, name and chemical symbol of a halogen. Time's up. And the answer is, you could put in the second to right column of the periodic table, these are the halogens under the number 7. And you could put F fluorine, Cl chlorine, Br iodine, and I, or Br bromine, I iodine. Got out of whack there, and I corrected it. And that's the periodic table, which you should be familiar with. speaking about familiar with, a special emergency public service announcement. If you haven't practiced with your calculator doing scientific notation, division, and multiplication, which I showed on Tuesday, and it's in the video, please do. Do it before the test. Do it this weekend because you should practice. You don't want to do it the first time on a test. Won't be good results, and I don't think you'll be happy. All right, now, we talked about, notice I used the word we, I talked, you listen and watch about where are the electrons. Remember in the nucleus, which Rutherford's gold foil experiment helped elucidate. Elucidate is a fancy word for help understand that the protons and neutrons are in the nucleus, which is very dense, but where are the electrons? They're in the shells, electron shells outside around the nucleus, and each shell has subshells. And the shell names are 1, 2, 3, 4. And if you look on your screen, everybody see on their screen, thumbs up, people, electron shells. Uh-oh, I think I have a strike of thumbs up, people. I see some, thank you. All right. This will be given to you. Notice this is from the file, test number 1, important information. And this will be the last page of the PDF file for test number 1 that I'll post next Wednesday. So you don't have to memorize this, but you have to know how to use this. And shell 1 is called 1, the first shell 1, second 2, third 3, fourth is 4. Number of subshells in shell 1. Shell 1 has 1 subshell, 2 has 2 subshells, 3, 3, 4, 4, and so on. Now, subshells are indicated by letters S, P, D, and F, and subshell S, you can put a maximum of 2 electrons, P maximum of 6, D 10, F 14. Now, remember my gift that you only have to know how to go up to calcium. I believe that's 20 in the periodic table. Let me check to make sure I'm right. And the answer is I am. Look out, I'm on a winning streak. You really only have to know the S and P subshells. Remember, it's a secret, S and P only. All right, let's do some practice. Remember, 1 is the lowest energy, 4 is the highest in the shell. So you always fill the lowest first before you go to the next one. And same thing here, S is the lowest, F is the highest. You always start at the lowest subshell, then go down this table. Remember, for the electron configuration, it tells you how many electrons each has in a subshell. A subshell name of an atom of an element is a number and a letter. The subshell name of a subshell in an atom is both a number and a letter. Now, we've gone through this. I'm going to see if you're up to it. Draw the electron configuration for oxygen. And what you need to know is how many electrons, and which is why I pulled up the periodic table. In case you haven't figured out, oxygen O has 8 electrons. And now that you know that, I'm going to go back to test number 1, important information. So you can use these tables to draw the electron configuration of oxygen, 8 electrons. Your turn. All right, I think everybody's just about done. I'll give you another 15 seconds. Hurry up. No, take your time. Oh, I'll give you another bonus 4 seconds. All right, time's up. Put down your pen and pencils, hand in your time. Oh, I was just practicing. Anyways, I would do that in a class when we're done. But anyways, let's do the electron configuration for oxygen. And thumbs up, people. Everybody see my whiteboard? Oxygen has 8 electrons. The first shell is 1 and subshell is 1s. Remember, a subshell is a number and a letter. How many electrons can you put in 1s? 2. How many subshells does 1 have? 1. And we filled it up. So now we go to the next lowest energy shell, 2. And the first subshell, lowest energy in 2 is 2s. Now I see a question, so I'm going to check. Oh, somebody was answering. Thank you, Lily. And we have 2s, and how many how many electrons can we put in any subshell, as subshell 2? So I'll put in 2. And am I done? No, I've got 4, and I've got to go to 8. Well, how many subshells does 2 have? And the answer is 2. The first one is, remember, subshell, number letter 2s, and the second one is 2p. Now, how many electrons maximum can we put in any p subshell? 2p, 3p, whatever. And the answer is 6. But if I do my math, I have 2 plus 2, that's 4. 8 minus 4 is 4. I only have 4 electrons. I could put 6, but I only need to put 4, and I'm done. So the electron configuration for oxygen is 1s2, 2s2, 2p4. Oh, let's do another one. These are fun. Ooh, let's do a hard one. Not really. Why don't you do the electron configuration for potassium? I'll give you 5 seconds to figure out how many electrons potassium has, and then I'll do it. 1, 2, 2.5, 3, 4, 4.5. Time's up. 5. Potassium K. How many electrons? You look at the atomic number 19. So potassium has 19. Let me pull up important information, and it's your turn. Write the electron configuration for potassium, 19 electrons. If you want, do a thumbs up, or I'll do the polling in a little while. All right, I think everybody's just about done. Let's do it. All right, now, if we look at the whiteboard, once I get it up, so we have potassium, 19 electrons. So I'll start at 1s, put 1, 2. That's filled now. 2s, 2. And now I have what? I have 2p, 6. So now I have 10. I have 9 more to go. So I'll go to 3. And 3, I have 3s, 2. So that's 12. And I think I just made a mistake. I should have capped it. But I made a mistake. But anyways, I've got 12. I have 7 more. So I go to 3p. That'd be 6. And then there are 3 SPD, 3D, 1. I didn't want to do that. So guess what? I made a mistake. And here's the mistake. I said we should go to calcium. Here's my correction. I'll only hold you responsible through magnesium. Let me do this. Bad, Dr. White. I was used to do that. Usually I do magnesium, and for some reason my brain went, and I said, oh, let's go to calcium. And I shouldn't have done that. So I'll only hold you responsible to magnesium atomic number 12 for electron configuration. Because I said I wouldn't have you do S and P, and that's that. Any questions on that? All right, let's move on to another area, and that's valence electrons. And you should know, what are the valence electrons? In my book, see my book here? Oh, that was an awful joke. But anyways, in my book, valence electrons are the most important electrons in an atom of any element. Because Dr. White messes with valence electrons. It's fun to do that. And what are the valence electrons? I think that's an A. I don't know. I always spell it wrong. What are they? Or you could have put an atom, and either one works for me. I see a question, and someone's ahead of me. I'm going to let you take over the class. No, I'm not. But thank you. That would be lazy of me. And today, now, question is, how do you know the valence electrons? As one of your colleagues already mentioned, you look at the top of the periodic table, either the Roman numeral or the normal number numeric value, and that tells you. And in this case, hydrogen is included in the first column. Hydrogen, like lithium, sodium, potassium, has 1 valence electron. Magnesium and calcium has 2. So I'm going to let you try some. How many valence electrons does sulfur have? Time's up. If you look on the periodic table, you have S, sulfur, and you look at the top. Remember, valence electrons are not denoted by the atomic number. Atomic number tells you how many all electrons. You look at the top, valence electrons, VI, is Roman numeral for 6. Sulfur has 6. All right, let's do a hard one. How many valence electrons does fluorine have? Time's up. Hopefully you all know fluorine chemical symbol is F. It's a halogen. And you look at the top, you see Roman numeral VII, which is 7, which I put down there conveniently in case you don't know Roman numerals. And somebody's getting them all right. Doesn't that feel good? I hope it does. And the rest of you too. Oh, let's do one more. This is an important element in our daily life, and that's nitrogen. How many valence electrons does nitrogen have? Time's up. Let's see what the, and someone else got it right too. And let's look at nitrogen. And nitrogen chemical symbol you should know is N. And look at top, you see V, Roman numeral, which is 5, as I have in red, so you can see it. And that's how you do valence electrons. Now, what I've just gone through this morning, the last, I don't know, 15, 20, 25 minutes, are things you should know how to do for test number 1. So if you don't, let's see, Jada, I will have in the assignment area, test number 1, the PDF file for the periodic table. I don't include it in the actual PDF file. It's a separate download. And also, if you go to the syllabus area of Blackboard, and I think I'm going to also put it in the lecture file folder, the same PDF file is available for you to download right now. If you want, print it out so you're all ready for test number 1, and you'll need it for test number 2, and you'll need it for test number 3. I think you need it for test number 4, and you'll definitely need it for the final. I see somebody already has the HTTPS, otherwise known as the URL. They don't use the address. And thank you. Thank you, Lily. All right. Any questions about what I just went through? Or anything else except the meaning of life? I still haven't figured that one out yet myself. I'm trying to at times. Anyways, all right. I'm looking at my list of things to do. And guess what time it is? It's time for today's lab. And today's lab, you can download from Blackboard if you haven't done it already. You don't need it now, but you will need it to finish and hand in on Tuesday. Remember, a lab we do today is due the next lab period. Today is Thursday. We have our labs on Tuesday and Thursday. And in the summer, if we were doing face-to-face, we'd have the same schedule. So on today's lab deals with calories of a nut. Calories of a nut. Well, how many of you have ever looked at a label on a food product and tells you how many calories it is, which makes it sad because the good stuff always have a lot of calories, you know, like potato chips and everything. What's calories? Calories is a measure of heat, and heat is a measure of energy. And when you have chemical bonds, which you learned about already, they have a certain amount of energy to hold things together. When you break those bonds, you give off energy. And when you make new bonds, you also make energy. Well, what's one way you can measure energy? A flame. And if you wondered, how did I figure out all those things? Let's take a look on the internet. Let me close this up because I don't need it. If you look on there, let's do some images. If you look over on the screen, does everybody see nutritional facts? Give me a thumbs up. Do you see it? Thank you. It says, and this is for I don't know which nuts, but for a serving, it's 270 calories. No wonder I gain weight when I eat a lot of nuts. It's high in calories because how much are you actually taking? 65 grams. So that'd be a small packet. Well, how did I get this number 270? Or if we look at other one, let's see, what's this? Almonds, it looks like, yes. Almonds, wow, no wonder I should stay away. 100 grams of almonds is 580 calories. Well, it turns out there are things in there that we can determine by burning this and measuring the heat when you burn it. And there's certain bonds, and a lot of it is fats and oils. Now, we do this experiment at COD and also at ECC, Elgin Community College. And years ago, when I was doing it at Elgin Community College, we're about to do it in about a couple months, maybe not even that long, a couple weeks before that lab, there was big news on the TV and other places about how a number of students were gotten, excuse me, very sick because they were allergic to nuts. And that was sort of new to me and a lot of people. And I was thinking, oh, we're going to do this with nuts and a lab where you burn it. If I have any students, that might not be good. So that class, I asked a week or so before the lab, anybody here allergic to nuts? And I had 3 people raise their hand. So I talked to the whole faculty and said, we can't do this lab. I can't with nuts. And we found out, guess what? Corn chips burn real good too. You'd be amazed and you'll see this. And nuts do too. Why? Because they're chock full of oil, vegetable oil, nut oil, and it burns quite nicely. When we get into organic chemistry section of this class, I'll teach you about what is burning, what happens when something burns. So today's lab, you're going to find out how many calories there are in a nut. Everybody see? Oh, wait. Yep, you should see it. Do you see calories in a nut on your screen? Thumbs up, people. Thank you. All right. So, as I said, heat is a measure of energy. One heat scale is calories. And you probably know this from foods. In today's lab, you'll be measuring calories in a nut. This is done by measuring the heat given off when you react to certain chemicals like fats and oils in a nut with oxygen. The reaction gives off heat in the form of a flame. And the flame will be under a known amount of water, and you'll determine the initial temperature of the water. And after you burn it, the final temperature. I'm going to show you a YouTube video so you can see what's going on if you were actually doing this face to face, and the difference between the starting temperature of the water and the final temperature, which is called delta T. In chemistry and science, delta means difference, T is temperature. This is a difference, can be used to calculate the heat given off by the nut, and thereby you calculate the heat calories in a nut. Now, when you measure this sort of thing, this is called calorimetry. And calorimeters can be very expensive, tens of thousands of dollars, and are very accurate. However, you're going to be using an empty pop can, which you put water in, which is not tens of thousands of dollars. But it's amazing how accurate a number you can get with that crude of equipment. Now, the difference in the starting and final temperature is called delta T. Now, each substance or liquid, a lot of them have what's known as the heat capacity. And for water, this is how much energy it takes to heat 1 gram of water, 1 degree, or actually 1.00 degrees Celsius. And this will allow you to calculate the calories in a nut. Let me do this. I'm going to go a little later because we're going to end early today. We're not going to take our break. So all right, before I maximize this, thumbs up, people. Do you see YouTube on your screen? Thank you. All right. Let me maximize this.
I'm going to be conducting the calorimetry lab with a peanut. The first thing you need to do is read through your lab and then make sure that your setup looks like mine does here. Make sure also that your stick for the food source is measured out as being only 3 centimeters away from the base of your can. So make sure to measure that. You're going to need 100 milliliters of water that you will pour into your can. The water temperature is what you will be recording initially and then after the food source has burned. Go ahead and place a thermometer into the can and let the thermometer adjust to the temperature. While it adjusts, I'm going to take the mass of my food source, which is a peanut. The mass of my peanut is 0.5 grams. You need to record that into your data table. The temperature of the water in my can is 24 degrees Celsius.
You don't have to write this down. I'm giving you the data.
Very carefully place your food source onto the pin. And then you need to start your food source on fire. I'm going to use a candle to do this because it does take some time to start the food source burning.
Not really if you know what you're doing.
Be very careful with matches.
You need to put the flame under the nut, which she's not doing, which is why.
Once the food source has caught on fire and is burning, I will go ahead and place it under the can with the water in it so that the temperature change can be recorded. You'll start to hear some little kind of clicking when it starts to burn. That is a little indication to you, like kind of popping, that the food source is on fire on its own. You're going to let that burn and heat up the water. Now that the peanut is completely burnt, you're going to check your ending temperature on your thermometer. For the data for the peanut, you're going to record a temperature of 33.5 degrees Celsius.
I'll give you this data.
You will be conducting this lab with 3 other food sources.
No, we're only doing one. All right, a couple things. When we do it in the lab, at least at ECC, I forgot, I think at COD, they switched to bread instead of nuts, again, because of nut allergy. But since it's all on the internet, we can use nuts today. First of all, she didn't know how to do that. We have a better holder at both schools, but you got to put the flame when you light it. And we use this lighters, not candles, right underneath the nut, or when you use a corn chip. And you'd be surprised how well, what kind of flame, some of those nuts, you get a flame on top this big. First time I did that lab, I was shocked how much fire came out when you burned them. But anyways, you would do similar what you just saw. And if you want, go back and watch the video if you want to watch it again. Now I have a video how to do calculations, but let me ask again. Thumbs up, people. Do you see how to do calculations on your screen in my lab? Thank you. Now, you will use the following formula to calculate the calories in a nut. The mass of the water, and this will be, we use 200 milliliters, which means that's 0.200 kilograms. The temperature delta T you're going to have to calculate, and the specific heat of water is this number right here, 1.00 calories per kilogram degrees C. It's formula A. Now, you'll weigh your nut and you'll get a before and after, and that tells you how much of the nut you're actually measuring the calorie content. Now, important calculation you'll be asked to do is the calories of your nut divided by the weight of the nut consumed gives you calories per gram. And I put down there how much it would be in real life if you read it off a label, and you'll determine how close you are. Now, in real life and in my lab, you're not going to get the exact same number. No, is your equipment calorimeter like about $10,000? No, but it's pretty close. I was amazed and always amazed when we do this lab face to face, how close that number is to the number you would see on the label. Because in the class, we'd have a jar of the nuts you're using, and I'd put on the board how many calories per gram that is. So if you go through the experimental procedure, I need some tea, my mouth is dry. That's better. You'd build a pop can, which I show you how to put the holders in using paper clips and everything. We do a little different, but similar to what you saw in the video. You'd add 200 milliliters of water, which is 0.200 kilograms. You'd measure the initial temperature. You'd attach the nut to a holder. And we found it's easier to weigh both the holder and the nut before you burn it. Then you put the nut under and the holder under the pop can. You don't want it too far away or it won't transfer the heat. That's why she measured it. We don't measure it, but I usually tell students, keep it about that close to the underneath the pop can. That's very important. So you get all the heat and then you light it. It's always fun to watch students do this. And when the nut stops burning, you measure the temperature again in the water, and then you measure the nut residue and the holder. And then we have proper way, you don't throw it in the garbage can, of disposing of the nut residue. The water in the pop can go down the drain, and the pop can, we usually set up a recycle bin for that. Now, since we're not doing it in class, I'm giving you the information, the data. Here's the weight of the water in kilograms. Here's the initial temperature, final temperature, the initial. Notice I have it numbered number 1, 2, and 1 minus 2 gives you your delta T, which you need. And you need the mass of the water I give you. Now, here's the weight of the nut and holder before you burn it. Or no, this one, number 4 is, or number 5 is before, and number 4 is afterward. Number 1, am I saying number 5? Number 3, 9.3724 is before you burn it. This is after. 3 minus 4, which is number 5, is the weight of the nut consumed. Now, you have to calculate, first of all, calories in your nut. Use formula A. And I've even made it simple. Use the values in red above, which you'll need this delta T. You'll need this mass. If we go way up here, you'll need this heat. So you put in the mass, 200. You have to calculate the delta T, and the specific heat is 1.00 that you put in there. And that will give you how many calories a nut. And you'll put that number here. Now, to get the calories per grams, you divide number 6 by this number 5. And it's right there. I've tried to make it straightforward and helpful for you. And then guess what? You've got some questions to answer. And there you go. And that's today's lab. You don't have to go on beyond Lab Z, even though I have a reference to that. They have a calorimeter in there. They don't have what I have set up. And I like to give you a real, like if we were face-to-face experience. Now, anybody have any questions about the lab? Going once, going twice, going. We're done with that. Now, I'm going to say goodbye in a second, but after I say, my goodbye, how I always do it, I will stick around, and any of you who would like to learn how to eliminate test anxiety after I say goodbye, stick around, because I'm going to cut that. How do you like that? Am I good or am I good? But anyway, oh, that was an awful joke. But anyways, I'm going to cut it out of I'm doing my scissors with my fingers, out of the video, because I don't want that floating out around the internet. Maybe someday I'll create a video and sell it and make a lot of money and be wealthy. Nah, but I still want to keep it private. So with that, I'm going to say goodbye. For those who want to stick around, stay after I say goodbye. So for those who don't want to stick around, I'm going to say, Gang gesund. I'll see you on Monday. And the answer is, will I post today's lecture? Yes. Everything up to now, I will post. As soon as I start teaching the method, that gets cut out. Just at the very end, you won't see that. Don't forget, there's a lab due today. And I forgot to mention earlier this morning in Blackboard, if you handed in lab number 1, I have posted your scores for that. All labs are 10 points maximum. And as I always keep on telling you, there's no such thing as a dumb question in my class. Therefore, anything I hand back, if you're wondering, why did I get that score? See me in private office hours, and I'll be more than happy to discuss why I did that. If we were face to face, I'd hand you back the lab and you'd see the red marks, but I don't do that for labs. But for tests, I will give back points for each answer you put on there, so you know what you got wrong. With that, I'm going to say goodbye, but stick around if you want to hear the method. So, Gang gesund, goodbye. And don't forget, study, do the practice problems, because test 1's coming up next week.